Everything we do to support foundries making more money. Everything that happens in the machine is actually, well, it has to happen so the parts coming out of the machine is sellable to a good price with a good margin. I had to be a little bit techy because measuring the solid fraction is very difficult because these melts are actually thixotropic. So the faster you shear, the lesser force you need. So having some kind of a torque and a stirring and data point, we have tried all that. We have done research on this for a couple of years. It doesn't work.
Hello and welcome to today's episode of the Gold Casting podcast. Today we are jumping out of what we know, the equipment, processes. We jump into a topic that is software and how to monetize that. And for that we have a special guest today. You might know him as my co-host Staffan, but today he will be joining as the marketing and sales manager of Comptech Rheocasting. So, welcome, Staffan.
Thank you. It's a pleasure being here. It's something I've been wishing for a long time, being the interview victim in this podcast.
That's perfect. So, I think before we start, can you introduce Comptech Rheocasting a little bit?
Yeah, sure. Happy to. Comptech Rheocasting started off as a foundry in the 70s, and it was a component foundry until just a few years ago. As a maximum, we were 30 die casting machines, 20 plus something in China, and actually 11 in Sweden. In total, I think 1,500 people. Full service provider components to especially telecom and on automotive. Things happened. The company was sold at the peak, being very profitable. To a Finnish owner, and then everything was moved to China, and the remains were pretty much bankrupt in Sweden. Then the owner family with Per Jansson took it over and said, okay, we will build a new foundry. It will be the experts in semi-solid casting, and starting off like this. And it went well. We did good verifications, but we were the single source in the globe. So we took a business decision to change totally from a component producer to an equipment manufacturer. So we pretty much get our hands on the patents for rheocasting, and we started this journey by developing machines and so forth. Sold the first ones in 2020. We have one casting machine left, and now we are 100% or 150% just working equipment that we combine with services. So being a little bit unique in this, I think, if you have been a foundry for that long, you know the challenges of running a foundry. And this is why everything we do, we think about how do we make our customers more profitable and making more money and finding new markets. That is the key question every morning, every night at Comptech. The rest is just welded things, PLC programming and some engineering. That's Comptech in a nutshell.
Perfect. Thank you for the introduction. So then the question from me and also from probably everyone that has been listening to the previous podcast, because it's not the first time that Comptech is on the podcast, what has happened now that you're coming back to talk about a thing?
Yeah, basically, if I had to be a little bit wordy now, but this is about business development. I mean, we decided to start to sell machines. We sold a bunch of machines. Now we are on the verge to be kind of hoping de facto standard for several applications out there. We're strong in Japan, we're strong in Asia, we're strong in North America. Europe is a little bit lagging, but we see good things happening here. With all these verifications for future platforms of cars, basically, we see more and more people from quality, both on foundry side and purchasing side, are asking two questions. Is it stable? And what solid fraction do you have? And for us, that has done maybe 5,000 quenchings of slurry, we know that it is stable, but we do understand that with the quality requirements in automotive, you have to have it on paper, basically. So then we said, okay, we have to develop a system so our customers, the foundries, have an easy way of determining solid fraction in parts, and also to look at the consistency of the solid fraction over time in volume production. So this is what we have done. We have made software that supports foundries and other interested people to determine the solid fraction in a part and or the melt itself. And this is pretty big, I would say.
Absolutely. And I would like to add, give a bit of a background information, because process stability in rheocasting is one of the most critical things. So rheocasting is around since the 1970s, with currently 87 different active patents on how to make that slurry. And the crucial thing is that also led to several casting parts really fail, hit the wall in the last decades, is that the process control and the process stability is the most important thing. And what all combines is that 99% or 86 of that 87 patents are temperature controlled. And when you consider that 20% solid fraction gives you a turbulent fill and 40% gives you a laminar fill of your part, and between those two is just 0.8 Kelvin temperature difference, and you can see how critical that temperature regulation is. And that is what basically killed all these projects in the past. And with your slurry maker, you're working with an EM or enthalpy exchange mass, or some aluminum ice cube that you melt off that has the same chemical composition, which then cuts out the temperature dependence. You just have an enthalpy dependence, and getting that right in a gravity die is quite easy. What then comes in what you're saying, that they have the proof that you have always the same solid fraction. And is that what the software is about?
Yeah, it is. It is. And let me be clear on a few things. Everything we do to support foundries making more money. Everything that happens in the machine is actually, well, it has to happen so the parts coming out of the machine is sellable to a good price with a good margin. I had to be a little bit techy, because measuring the solid fraction is very difficult, because these melts are actually thixotropic. So the faster you shear, the lesser force you need. So having some kind of a torque and a stirring and data point, we have tried all that. We have done research on this for a couple of years. It doesn't work. The signals will be too small, the deviations will be too big. I mean, no one is helped if I tell you that you have a solid fraction between 18 and 45%. It has to be more precise. So then you have a problem definition. You have to do a metallurgical sample. And how do you actually push for that and do all that with all that experience in an industry with 80-90% of the foundries are actually casting one alloy and they're happy with it, and they probably haven't seen a microstructure picture since they were in school. So we took that and then we started to analyze it, and then we found out that, yeah, the best way we can do is actually offering the service where you upload a sample into our system and you get back a figure that is verified and safe, telling you this is your solid fraction. That simple it has to be, because we also put some burden on the foundry itself here, because they have to do a pretty basic polishing of a part or a melt and then upload it. That's their job. We take care of the rest. So I think this is something we have to have, especially in automotive, to be successful all the way.
That's interesting. So then the big question is, how does it work? Is it AI, machine learning, or is it a few guys sitting behind it doing the analyze and then uploading?
No, the calculation itself is actually based on machine learning, and it's been developed together with we have a PhD, Julia, a very, very smart, bright young woman, and she has been with us now for several years working on this, and she makes half of her, or 70% of her work time is actually at the University of Jönköping. Why this is important is that there are many professors out there, and we love them all. They have different areas of expertise. And Professor Jarfors, who's head of this department, I would say he's the global expert on slurry formation, nucleation, and the slurry itself. So it's a perfect fit with our industrial PhD working with Professor Jarfors to really ensure this is bulletproof. You can trust this figure when it comes to your desk. So machine learning, absolutely. So we're combining modern software methods with good old-fashioned metallurgy. And the result is that we can offer this service of people being safe when they actually say, I got 36% solid fraction. This is what I aim for a part like this, for example. So that is basically what's happening. Now, the first steps. People are uploading already via email, getting a result. Somewhere during next year, before summer, I hope, this will be fully automated. So you upload and then 5 minutes later you have the result. But for now, we want to have people behind the curtain also because, again, it has to be safe, it has to be verified, it has to be quality stamped. But when we have, 1,000, 2,000 pictures analyzed with a bulk that we have already been doing, then we can start to trust our machine learning and functionality.
When we talk about the history, or you said with the Comptech history, started as a foundry, went into equipment manufacturer, is now the next transformation of what you're doing into software development. How does that work, and what's the difficulty of yet another transition?
It doesn't in the beginning. It doesn't work at all. Yeah, despite one success factor, it doesn't work at all. We're sitting there around the table. We're a bunch of middle-aged guys. We have a very energetic PhD, being 25-something, And when she started to speak about these things, we went like, really? Okay. But then when we started to understand how her problem description fitted into the research field that she was claiming was the future for semi-solid casting, because of the hinder of quality, safety, stability, securing the quality and all these things, then we started to realize that, if we're going to make money on this, we need to have this. So the answer to your question, it didn't work in the beginning, but the key element here is that our owner, Dr. Per Jansson, is pretty much a tech visionary and doing stuff that no one believes in and testing stuff no one believes in. So he kind of gave her green light to make the first mock-ups, and then this development started. If it wasn't for having a technology visionary with a background of running a foundry, then I think we will still trying to figure out a mechanical solution to this.
It's so interesting that you said it coming from, especially like everything in the foundry, it's always hardware based. If you have a problem, you buy a machine. And now you're saying, okay, we have to take it totally out of that machine thinking into the digital world. So then you have it now, it's working, you're double checking it. So how are you going to introduce that to the market?
Well, first of all, as all foundry guys, when it comes to marketing, even if we're working with this podcast, we still have a lot of things to learn from people like you, Fabian. But where we are right now is that we have the official global launch at the Eurogas, where we will show this to people. But we have pre-start, especially when it comes to gigacasting projects, where when people are doing trials, they are using this service, both in Europe and especially in Asia, but also in North America. So then we do an agreement. Okay, guys, tell us decently when you're running your test, and then we are sitting there in the office and waiting for the pictures to come, basically. So it has been started towards the major OEMs for beta testing, I would say. But then it's about the Eurogas, it's about this podcast, it's about LinkedIn, it is about conferences where we have the researchers. So we try to we actually have a matrix with people, roles, and organizations that we try to get this bingo, where you have check in every box, in every aspect. It's a vision. It's my dream, but we also have a priority to get this going. But see it from my perspective. We have motorcycles in India, we got telecom in Sweden, we got cars in US, we have development projects in Japan. How do you cover it all? You cannot do it the traditional way and drink coffee and say, I know that guy that knows that guy. You have to reach out, because we cannot know which quality engineer is sitting there and saying, oh, I would love to see this happen, but how do I know that it's stable? We don't have the name of it. And to be honest, I don't think the guys in the project management of the projects on top level that we're working with, they don't know him either. So that's marketing for
but
you.
He's
Reaching
the showstopper. If he cannot verify what's produced, he will be the showstopper, and you don't know him, you will probably never talk to him.
I think showstopper is a critically loaded word. Let me take the perspective of quality guy. We have seen so many new things on this globe that has failed. And of course, their job is to secure that when you buy your new car, it works. It doesn't fall apart. And he's actually the guy taking responsibility for it, and he's not overpaid, and he's not running a Porsche somewhere, and he has to be sure. And if everybody,
Absolutely.
Yeah.
And that's what I mean by showstopper, because you not can put up a show and then deliver crap in the back end, because that has to also commit to your original message. And that's why he is there, or she is the gatekeeper to secure that your output is the same thing that you put on the presentation at the beginning. And for that, he needs measures. So it's easy if you have the geometric variations. You have measuring device. You can measure point to point, or have the fully part scanned and have a perfect measurement. But with the slurry, it's more difficult. As you said in the beginning, if you share it differently, if you have a different temperature, you impact the result. Therefore, you need really to get something that is actually from the part or taken out of the slurry in the same way every time. And the best thing is to have the part, because then you actually know what the effective solid fraction is.
Yeah. And then when we talk with our guys doing this since 2006, they go like, we know it's stable. We have done 5,000 quenchings. They can come here and look. And then it's exactly what you're saying, Fabian. Yes, but I have this shock tower in this alloy with this alloy distribution in chemistry. How does that vary? Probably not much, but why not check it? And now you have a tool to check it for a low cost. I mean, isn't that good? Because if we would trust everybody saying, trust me, I have tested it before, I doubt there will be any people left on this globe, or at least men, because we're easier to fool. We will be extinct. So thank you, dear quality engineer out there taking care of us.
Absolutely.
Anyway, but you you were asking about the problems. Okay, you have the picture here. You got 4 or 5 guys, middle-aged guys, some metallurgists, some mechanical engineers. In comes this 25-year-old woman and start to speak with many words per minute about how smart it would be to have AI, machine learning, and blah, 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 metallurgy, and ding, 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 ding. And you go like, yeah, okay, please check it a little bit more and try to define it. And then she comes back after 2 weeks, start to actually, you see the contour of this cloud. And you start to think, this is the question I get all the time. Is it stable? Is it reliable? How does it work over time? What solid fraction do you have? And you go like, yeah, great. And off she goes, I'm working marketing and sales, so I'm not on technical meeting every day. And then 1 year later, you actually have a solution. Then you have the next problem. How do I launch it? What is my business model? How do people understand this? These people developing this, they are PhDs and doctors and professors. How do you think the manual looks when these guys are doing it? I love them. They are super competent in many ways. But making a manual for the guy that 3:15 in the morning is going to quench a sample and send to his customer. I mean, come on. These guys are not stupid, but it's still 3:15 in the morning. So again, whatever we develop, it has to be user-friendly, stable, verified, and super easy and to a decent cost. So then you have another set of limitations for your development. And not only that it should be super nice and it will give the technical solution to a thing, you have the other things. And that is you ask about the problems, then you come into the next wave of problems. I mean, again, 5 middle-aged guys. And 3 out of 5 will say, yeah, but you have to understand to use that grinding paper when you do the polishing. It takes only 3 minutes. And you go like, okay, but 70% of our market has never made a metallurgical sample. Yeah, but that microscope costs you like, 500 euros on eBay. Yeah, but do they even know what kind of magnification you need? Yeah, but you don't take a photo. You have a digital thing here. Okay, where do I buy that one? And what's the resolution of that one to make our system work? All these things that comes after the genius has spoken. And here lies, I think, the challenge making a software.
Then you have to verify the magnification and the sizes in the picture. And these are the things that then also done by software occur on that. And when you know these microscopic softwares, they are not cheap. And I'm just guessing now, because when you launch a software, that gets into a lot of pre-phase testing.
Yes.
You have development costs. You probably had to hire an external developer for that. You have, when we talk about machine learning, you're talking about GPUs. GPUs are crazily expensive.
Oh, yeah.
You can see it in the
Yes.
company valuation of NVIDIA.
Yep.
So you have the cost already. The question is then, how do you get paid, and what's your business model behind it?
Oh, yeah. Now it's very simple. You buy a package of samples, and then it counts down. So if you buy 5, 10, 20, 50, you get more and more discount the more you buy, of course. But we have to get paid. But honestly, this is the thing that stands in between me and a lot of machine sales. And if you translate that to foundry language, this is the thing, or one of the bigger things, that stands between my foundry customers and profitable business. So everybody wins. I have to sell more machines. The foundry needs to buy more machines because they get more and more nominations. And that's a good thing. So are you going to take a profit on the swings or the carousels? I think you need to have a holistic view of what you're doing in a company. What's different, though, is that in the former days, we were making components. The turnover was the number of delivered parts times the price list. Easy. This is a grayscale. And and I said, if you're speaking about profits and how to charge for something, you need to know how much did it cost. Do we know how much this costed us? No, we don't have a clue. And here I'm laughing because it's a little bit of a circus at Comptech sometimes. I said that the key element that made us take this step is that we have a tech visionary as a CEO. Because here comes the thing, if we would have done a budget and in getting to a number, I don't know, 500,000 euros for a prototype, would we have done it?
No,
We
probably not.
Yeah, and we probably would have started to look for grants and delay the thing 2 years, and then the whole rollout for certain application will be delayed for 24 months because of 500,000 euros. But coming back to it also, when taking a decision to do it or not, do we know it's 500? Well, I mean, the salaries of our industrial PhD is pretty easy, right? That's a calculator, and that the monthly cost, and then you have some bells and whistles on top of it, and then you have a number. How many hours have I spent? The rest of the organization spent? How much aluminum have we thrown away? How many conferences have we sent our team to? But then they're discussing 4 different questions. Okay, are we going to divide that cost in 4 piles? And I mean, and it's impossible. So in somewhere, you have to go a little bit on the gut feel. And that is why that the key success factor as CEO, that is a technical visionary. End of story.
I think with many of these projects, you're speaking to so many things that would have massive success throughout the industry. But then at the end, it comes to an Excel sheet where some controller sits, okay, we have projected costs of 400, 500,000 euros, and we don't have a market projection what we can get out of it. So our ROI is massively negative. Look here in my Excel file, it's deep red, so we cannot do it. And
Exactly.
You can kill innovation that way very easy, and you need to do new things to succeed.
Yeah, I mean, you can take so many examples in life where these small things, maybe not that costly, hinders you from doing a lot of things. And again, a holistic view. But you have to realize that this team sitting around this table, I mean, it's no secret. It's Per, Staffan, Patrick, Pattan, Elin. We have gone to the same address since the 80s, some of us. We're foundry guys used to components. And that culture change, I mean, now people are getting used to Per Jansson inventing crazy stuff that 5 years later seems to be a very good idea. But, and here comes to be serious, one of the key issues. If you're going to do something that lies so dramatically out of your comfort zone, you need to hire people that actually can work with it. And you can see the faces of those middle-aged guys when you have a 25-year-old, talking about machine learning. Now, not in the future, not speculating about things, but or AI or whatever we call it. So recruiting those people, and how do you judge the profile of someone when you had never ever recruited someone with that profile?
You have to judge, especially when you're not working on a massive venture capital budget and you don't know who to hire and how to check if that person is a quality software developer or not, because you have to go and also need someone that says what you're doing is the right thing and I can give you an idea. And if I don't know how to move forward, I'm so determined to find it out and to get to a solution. And I think so many projects die in that process, making it the perfect plan that you just can follow the milestones, or you see very quickly that your milestone plan goes in a totally wrong direction, but you got a grant for it and you have to finish that work piece at the end. So you follow it along, going in the wrong direction, and then you kill it afterwards because you don't want to pay back the loan. But what you did, you basically just bootstrapped it, put it out, and then say, okay, we have to deviate here, then we have to deviate here, and then you get to a solution that actually delivers what you need and takes that, how do you call it, dynamic approach or
unplanned, situation-based, or
exactly, goes more from that strict planning that we're used to as component manufacturers into that agile software development environment where you have constantly work with requirement changes because there's interaction between certain pieces of your software. And that's something that you really need to manage, and that you need strong leadership in that. And then I think you can also now make a quick transition to your favorite episode of the podcast.
Yeah,
when you talk about leadership.
Captains? 37 clicks. Come on, guys! It's the best one. It's recorded in my favorite place, also my cabin, in a very ugly shirt, but it's still the best episode of this podcast. But now I need to change the subject. Yes, we do this to help our customers make more money, to get the final questions before the nomination, basically. I mean, this is basically the immediate thing we are looking for here. But then you can think a little bit 5-10 years. And if you look what's happening with topology simulations being very good today, if you compare it like 10 years ago, 15 years ago, meaning two platforms in car industry. If you look at the casting simulation, even with semi-solid and liquid casting, we're going very, very well. You see a lot more and more machine learning. We have interviewed with people in this podcast about different softwares for DFX, if you put it like that, that are smart, that pinpoints things out of machine learning. If we don't have something that support us in the amount of data that goes into all these models, we are not a part in the game. We're not in that race. And if you think about it, this is strategic important.
Yeah, and also when you think about that, with the amount of data that is now very easy to generate.
Yes.
And you have a poor guy sitting there that has to quantify that and analyze it and turn that massive amount of information into a thumbs up or thumbs down. That is so much of us in asking that you need some smart tool that can handle that difficult thing and make it easy to make a decision based on all the information. And machine learning is actually the perfect solution for that.
Yeah, that's when you're taking a decision. But let me give you another perspective. You're going gigacastings. You have a bunch of 6,200 ton machines or whatever brand. On the other side of the wall, you're going to deliver one rear floor every 60 seconds, one battery tray every 60 seconds, and the front cradle every 60 seconds, okay? These are massive investments. Yes, gigacasting exists, but it's the first version. How do you get data for trimming the casting process, the design, the tool design, the cooling system, and all these things if you don't have a lot of data? And today we can handle data. We have something called machine learning. And this is going to be the new platform of casting development. And this is a shift from where people could walk around with I don't know, up to 1,600 ton machines in the family-owned business. They knew everything. They can smell a problem. But now you have 20 guys running around because every % of production improvement or quality improvement will be millions of euros in each and every site like this. So the money on the table is 100 times bigger. So a small software from us, a nice software from the machine maker, good data sheets directly imported from the alloy perspective, the measurement, the scanning of the geometry, AI for looking at cold shots, flashes from the tools, the coolant system performance, the in-water temperature, out-water temperature on those 190 jet coolers in one slider. It's here, the solution to knowing how to optimize lies. And this is very important if you look at gigacasting. So immediately now, the response from me will be, helping founders to get nominations and get money out of their investment in Rheocasting. Middle term, I would say middle term. Optimization of gigacasting production 2027 and onwards. That's the key.
I think that's a really noble and challenging goal, starting with the most complex castings. But you're totally right. These are the castings where the most development comes in, and you get also the easiest cost saving. One car costs 60,000 euros. If your gigacasting is not going right, you now have 60,000 lost in sales because of the wrong gigacasting part that you have to change out later. So if you don't have a bad part, you just made 60,000 euros per minute.
Yeah, that's one perspective, but look, I think there's even worse. Recalls. What if you produce every 60 seconds? Everything is nice and cool. Then someone finds out that, the iron content in combination with the silicon content of your alloy, it was actually a malfunction here because someone did a mistake. So we produced 1,000 cars with the wrong alloy, meaning we have off-spec elongation. How do you do a recall on a rear floor problem in a car? Changing a water pump, you can do it. Tires, you can do it. Somewhere around the unfeathered weight, you can do it. But how do you disassemble a car for something wrong in the battery tray or the rear floor? It has to be right.
Exactly. And the only thing you can do in that point is just take it back, because if you change out the gigacasting, it's basically like crash car, because you have to change the whole underbody, and that's a massive undertaking. So you have to be sure. And for that, you have to have the right solutions to help you get everything right. So is that also why you said, okay, we put that investment in money and time into it to make it right?
Yeah, because if you look at our market, I mean, we have good customers in two-wheelers and air conditioning systems and things like it. Love them. But I can sense and I can smell the best budget, the most decisive projects are actually gigacasting projects. And that's where the money lies, and the saving for the car makers, and you have to go with the flow. I mean, you have to sell where you can actually sell. I mean, we're not betting money at Comptech. We're a development company. Guess if it costs something. So we have to be there. But I'm sure that the way of build a car is a de facto standard now with a casted rear floor and a battery tray and all that. It's just to adapt it, and now comes 20 years of development how to optimize it. Because basically what we have and see now is a new design in new machineries. Too new. That's one new too much. I learned in ABB when I worked there. So short term, helping our people out there, our customers, I would like to say partners, to be more successful, making more money. Middle term, definitely gigacastings. Long term, merger of disciplines, meaning boiling all these data together to make the final, to yet take another step in optimization of casting of gigacastings. That's how I see it. But it's only my view.
Yeah. And I think, especially coming back to that new, for you, developing a software was something totally new. And there are probably in our industry, every company that has some specific problem where they need a proper software to do it. So can you shine a light a bit on your key takeaways from that software development that can be as a learning point for everyone else who wants to use their own software in their companies?
Yeah. Now, I haven't been in the project every day. I'm just a frustrated sales guy. But first of all, basic, identify the problem, define it. And don't be afraid of calling the people that you think is whining, because whining is actually a symbol or a signal that something is not right and you need to do something. If someone is complaining and thinking and saying that, yeah, we cannot use this because of this and this and that, I mean, 50% of the time it's probably just an excuse not making an investment, but 50% of the time it is an actual problem. They have a customer that refuses to nominate them because of blah, 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 blah. And then you have it. So that's one thing. And then the second thing is to recruit people that actually can solve the problem. In this case, people that wants to dive into software, different machine learning models and all that. And then they go, and they ride along on the prairie like Lucky Luke. And then you have to not restrain them and not to mess too much, because they need to be creative and find these beautiful solutions. But you have to, someone in the team, I would say, has to take the customer perspective. Is it easy to use? Because complicated things never get used out there. It has to be easy. That's why we have electrical start engines in ICEs, for example, because, going out there and turning that thing was not easy, and people hurted themselves, and it was messy. And how do you manage the throttle when you're trying to start your engine? I mean, it has to be easy. And then comes the next thing. You start to have something. It doesn't have to be a software. It could be a new product or whatever. You have to try to think it through. How does this affect everything? Because I can bet you a couple of things. Accounting. All of a sudden you have a new business model, for example, and people are buying like 25 samples of you. And then they order number 1, 2, 3, 4, 5. And then the month ends. And how are they going to manage this and the bookkeeping and blah, 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 blah. So it starts everywhere. The R&D guys, we start to have a lot of questions like, yeah, okay, it differs 3% because we have this magnesium and this copper content, which is blah, 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 blah. And all these things, you have a new business model. How is sales going to deal with it? Well, okay, that's maybe print them a new brochure and then you're good. But you have distributors also. So how do you train them? And you see, you have to think it through. How does this small change actually affect all these functionalities like sales, ordering procedure, your customers, boom, 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 boom. And then I think my personal takeaway, I hate bar desk discussions where people say this is priceless, we can charge 1 million Swedish kronas or 100,000 euros if you like. Show me a software that is that expensive. Yeah, simulation software maybe. But as soon as you have something that starts to have a decent volume, like Spotify, then it becomes cheap. And it lies in the volume. And one has to think about this, because the more user data you get, the better product you can do. If you are selective and have a few customers, you have a few inputs. And maybe you're just a club of people being interested in measuring solid fraction. But if you want to get it out there on a broad perspective and get it used, it has to be simple to use, low cost, simple to buy also. And then again, nothing is ready. It ain't ready until the fat lady sings, as Will Smith says in one action movie. And remake and constantly develop. Because again, if you do something new out of your comfort zone, the chances that you will have the perfect product the first time is zero. New functionality, new things people are asking. Maybe you get side questions. Does it look normal? How round are my alpha grains? Maybe we have to put in a standard distribution number as well. I don't know. It's in the future. Maybe people don't ask about it. So that means that going back to the first point, second point, recruit people. Maybe you shouldn't send them home directly when they have done the first version, because then the work starts.
Yeah. Then there comes the interesting thing when you really do the final adaptations to make it perfect for the customers. But I think I have to ask you the key questions, because now your wallet is way lighter after the development.
Oh, yeah.
You're now much wiser. Would you do it again?
Absolutely. Because it solves a major issue in semi-solid casting and semi-solid industry. Regardless of what process and what you're doing, it makes life so much easier for so many people, and it drives so many important decisions. So would we do it again? Absolutely.
I think that's the perfect answer. And then that you had to, even if it starts messy, you get something that you really love and stand behind it. So then for everyone listening, and are interested in measuring their semi-solid to get a clear output, go or no go, come to the Rheocasting Pavilion, go to the booth of Comptech, talk to Staffan, talk to Per, and get more insights for your application, I think.
Yep.
Or any final words from your side?
No, not really. It's been a pleasure being interviewed in this exclusive podcast, and I look forward to maybe I can get invited again in a year or two. And again, dear listener, swing by. Let's talk about this, at least, if not about the software, about the experience, doing something different. So see you at the Eurogas 13th of January at the Rheocasting Pavilion.
And in the meantime, don't forget to subscribe to the podcast, because there will be a few more episodes that prepare you for the Eurogas, that you know where to look, where to go, and we both will be there.
Yes.
And until then, see you in the next episode.
See
Goodbye.
You. Hej då. Wiedersehen.